Hi, welcome. I'm glad you're interested in the Gebbie group. My name is Rishikesh and I'm a first-year graduate student. I'm here to introduce you to our office. Here is our workspace. This is where all the graduate students and postdoctoral researchers hang out. As you can see, we have all the daily amenities you might need. But you're probably a little bit more interested about our research. I'll kick it off to Bei Chen to give you more details about that.
Hi, my name is Bei Chen and I'm a third year. Let's talk a bit more about what we do in the Gebbie group. Here in the Gebbie Lab, we apply techniques from many diverse fields, including electrochemistry, catalysis, energy storage, and soft materials, to answer fundamental questions that promise to progress knowledge of energy, interfaces, and sustainability. Our lab is entering our third year of research here at the University of Wisconsin, and we are currently pursuing 3 research directions. The first direction is the study of ionic structuring at charged interfaces using nanoscale force measurements. This direction fits in with our aim to understand how ion structuring dictates energy storage at interfaces. The second direction is the study of nanoscale ion transport processes in electrolytes. Here, we aim to understand how unique materials can provide efficient and selective transport of ions for a new generation of energy storage devices. Our third direction is the study of ionic liquid-based electrocatalysis for sustainable synthesis of valuable commodities. Here we hope to understand how detrimental carbon dioxide can be turned into a valuable resource to reduce greenhouse gas emissions, leading to a more sustainable chemical production industry. With that, you're probably curious about what our lab is like. Let's hand it over to Seth to give us a tour of the lab space.
Hi everyone, I'm Seth, a first-year grad student in the Gebbie group, and I'm here to show you around our lab space. Let's go on in. Don't forget your PPE. On your left is our laser lab, where we're finalizing the installation of some really cool new equipment that our buddy Ryan will walk you through later. As you see, we have a really nice, open, and modular lab space so that we can move equipment around as needed depending on the project. Take note of the large open windows. They're the best part of the lab as they let plenty of sunlight in to keep us happy. Let's go over here. In this room, we have a larger sample preparation area and a room dedicated specifically to sensitive surface force measurements. Now we'll hand it off to Jack to talk about the surface force measurements.
Hi there, my name's Jack. I'm a third year in the lab, and my focus right now is intermolecular interactions and ion solvation in our ionic liquids. One of the tools we use to measure such forces is the surface forces apparatus. With this piece of equipment, we can bring 2 surfaces into nanometer confinement with each other and measure the amount of forces that are either pulling the surfaces together or pushing them apart. Now, this is a really exciting portion of our field and kind of highlights the aspect of our group of what it means to be an ion and what it's like to be surrounded by other ions. But another person who can tell you more about this is Bei Chen, and we'll check in with her in the main lab.
Thanks, Jack. So my work is primarily in electrocatalysis, which means that we're studying and improving upon sustainable electrochemical reactions. So for instance, I work on CO2 electroreduction in ionic liquids, but this work can be easily expanded out to other kinds of sustainable electrochemistry. So for our work, we primarily use a potentiostat to control what's going on in our cells, and then to analyze what's coming out of our cells, we have different kinds of product analysis methods. Most of our ionic liquids are commercially available, but we do synthesize some unique ones in-house. Now let's check in with Ryan at the laser lab.
Thanks, Bei Chen. My name is Ryan Cashin, and I'm a third-year graduate student here in the Gebbie Lab. Welcome to room 2112A, a subset of our larger lab space that we'd like to call the laser lab. Here, you can see our optical microscopy setup. This is one of the tools that we use most to study energy storage devices and interfacial sciences. Here, we have the setup placed on a floating optical table, which allows us to do vibration-free measurements. And this is essential because we're really trying to study nanoscale mechanisms of ion transport. One of the unique aspects about our microscopy work is how much control we have over the optical path. We are currently working on setting up our free space lasers to enable unique fluorescence microscopy measurements that probe the motion of charge carriers through various types of electrolytes. We have beam splitters, pinholes, periscopes, and a variety of optical filters. The intersection of spectroscopic methods, optical microscopy, microfluidics, and electrochemistry makes us a unique lab for studying how charged species move in energy storage devices. That's all for me, so let's check back in with Elvis at the office to talk about some of the data science approaches in our group.
Thanks, Ryan, and welcome back to the office. I'm Elvis, and I'm a first year in the Gebbie group and co-advised with the Zavala lab. Here, I work on applying data science to electrochemistry. Primarily, I'm looking at predicting ionic liquid properties, in this case conductivity, using machine learning and optimization techniques. The ultimate goal is to identify promising ionic liquid candidates for future experiments. So that's a quick overview of what we do in the Gebbie group. But before we go, I'd like to share a little bit more about our group. Our group includes 6 graduate students, 3 undergraduate students, and 2 postdoctoral researchers who work together in a collaborative research environment that facilitates growth both as an individual and a team member. As a new lab, we enable students to pursue research directions that match both their individual interests and our larger group goals. I hope you enjoyed learning more about the Gebbie group here at the University of Wisconsin. We wanted to make sure you have all the information you need to make the decision that's right for you. If you need any more information at all, feel free to visit our group website, our group Twitter, or contact us directly. Thank you so much for watching, and good luck with your upcoming decisions.